Welcome back to module 10 of object oriented analysis and design. We have been talking about minor elements of object models. We have already discussed about the aspects of typing, the strongly and weakly typed languages, statically and dynamic typed languages, and we have talked about polymorphism. Next, we talk about the second element, which is concurrency. Concurrency is as the name suggests, is relates to two or more things happening together in the same time. So, if I have one object O1, if I have another object O2, I have another object O3, and these are between themselves sending different messages and expecting to get service. We have seen this model, then certainly you cannot have a sequential or well ordered structure to do this. You want all of these to happen as and when they need to happen. So, while O1 say is sending a message M1 to O2 to get a service, at the same time it is possibly getting a message M2 from O3 to provide a service. Both of these have to happen at the same time. Now, this is known as the concurrent behavior, and at the same instance it is also possible that I have objects like O4, I have objects like O5 who are just sitting idle, who are neither sending messages nor receiving messages. So, they are not actually doing anything. So, the concurrency is a property that distinguishes an active object from an inactive one. These are the inactive ones, and these are the active objects which are doing something or the other at the same span of time. Certainly, you can understand that without concurrency, the abstract client server model that I talked of earlier as a basic computing model of object based systems would not at all work, because I cannot have an ordering of exactly first step 1 has to happen, then step 2 has to happen, message 1, message 2, message 7, message 6. I will not be able to, we will not be able to define this single temporal order for things to happen. So, concurrency is a very necessary part of the object model of the typical systems that we work with, and this is a cartoonist's view of what happens inside the body of a cat who is wagging the tail and digesting the food, and at the same time trying to hunt something for itself. Coming to a more mundane example, which I am sure would be closer to your heart. All of you I am sure use mobile phones in different aspects. So, here I am just talking about different scenarios. For example, you are on your mobile phone, suppose you are editing your address book, you are adding a new friend. Now, while you are doing this, apparently your focus is on editing the address book, but at the same time the phone is doing a lot of other things. For example, at that same time it has to remain connected to the base station. Being connected to the base station is, we commonly say, no, my phone does not have signal, my phone does have signal. That is a kind of visual indication we get. What it means that it is being, there are land stations called base stations to which my phone is currently communicating and is connected, and all the time when our phone is live, when our phone has towers, it basically is connected to the base station. So, it is not acceptable for us that while I am editing my address book, my phone does not remain connected. So, regularly it is sending certain information to the base station, it is getting some information from the base station, again sending information, getting information. So, this task and this task has to happen concurrently, and while this is going on, while I am changing the address book, I certainly receive an SMS. So, the delivery of the SMS happens when the phone is connected, when I am editing the address book. During that time itself the SMS get delivered, and as the SMS is getting delivered, it is being put to my SD card, a notification pops up by the side of my address book screen to tell me that an SMS has come. So, that notification raise has to happen. So, if you look into all of these, they will need to happen concurrently. There is no specific ordering strictly between all of them. Of course, SMS being delivered will be followed by notification, that there is an ordering there, but there is no specific ordering in terms of how much I edit in the address book and the SMS being delivered and the connection of the phone. In a different scenario, if while we are in a call, the phone certainly needs to remain connected to the base station. So, this is the call is a task, this is a task, another SMS can get delivered, and in fact, a second call may arrive. So, I get to see that a call waiting is happening. So, the ongoing call and the waiting call have to happen in the same time space. So, this needs concurrent behavior. You are watching a video in your mobile phone, you are still connected to the base station. So, while you are watching the video, without disturbing you, an app is getting downloaded and updated, installed in your phone. A WhatsApp message is getting delivered and you get a notification for that is raised. All of these happen in the same time space. There could be, if you start just thinking of different instances of your use of the mobile phone, you will for every kind of scenario, you will identify 4, 5, 10, 20 different things that need to happen, the tasks that need to happen at the same time, and without a predefined order, a strict predefined order for things to work properly. So, that is a basic significance of having concurrency in object model. So, if we think about all of these address, if I think about say the address book is an object, if I think about base station connector is an object, if I think about SMS is an object, if I think about notification is an object, if I think about call as an object, if I think about app as an object and so on, they all will need to interact, exist and work at the same time domain. So, that is the basic notion of concurrency that we need to work with. Certainly, coming to the technical terms, concurrency basically relates to processes in our computing system, and we often talk about two kinds of concurrency more frequently. One is known as a heavyweight concurrency, or which is commonly called a process. The other is known as a lightweight concurrency, which is commonly called a thread. A heavyweight concurrency or process is an entity that the OS deals with and provides its own address space. In contrast, a lightweight concurrency happens within a single OS process, which is a heavyweight concurrency item, but it shares the address space that the heavyweight process or heavyweight concurrency of the process has. It does not get a separate address space. It shares that with other lightweight processes and so on. The communication typically is expensive between processes or heavyweight concurrency items. It is usually through a shared memory in terms of lightweight concurrency items or threads. So, these different kinds of concurrency models has to work with the way I want the objects to interact. If so, naturally objects which belong to the same module, objects which are closely integrated should work concurrently using threads, whereas very different modules which are completely independent, which have very little functional overlap or very little code overlap, would possibly work as independent processes, because they need to handle very different independent resources of the same system. So, as you go to the refinement of the design in terms of your object models, you might need to look into these concurrency aspects of the object models. We move on to the last minor element of object model, that is called persistence. Persistence basically talks about two major axes, axis of time and axis of space. We have been talking about objects all the time. Now, finally, when I realize in a programming system what is an object? An object will be represented by a contiguous sequence of memory locations, a collection of bits together. So, there is always a beginning of an object. An object gets created by some other object, because everything is object. Once it is created, it occupies certain memory space and it stays for a certain period of time till it is destroyed. Now, in terms of time and space, many things can happen. For example, an object may continue to exist even after it is created ceases to exist. Somebody created that object, but that whoever created that creating object has been destroyed, but the created object will stay. How long it will remain is an independent factor in the design. Similarly, an object's location may move. A object may have been created in this memory space of thread 1. Here I got an object. This is my conceptually this is my object, and this is what it has got created in terms of memory. I may move it to some other, say thread 3 at a different location, and say now this object has, I want a blue. Now, I say that this is where this object has gone. This is the same object, but I may change its location. So, the space and time of an object can go through different kinds of transformations, and how those happen is addressed in the issue of persistence. The cartoonist's view for you to enjoy. I will not go into explaining this, you should take your time off and try to understand what is being said in the persistence here. Let me focus on the fact that persistence built a continuum of object existence. As we have already explained, an object, let me get back to red, that is more prominent. So, an object in a software takes certain amount of space and exists for a certain amount of time. So, how much? So, if we just look into these two axes, say we say this is time and this is space. So, we will have objects in different points in this space. So, the further down you go on the right here means these are objects which stays longer. From the creation to the destruction is a longer time. If I go on this, then it says that these are objects which move between more and more number of spaces, address spaces. So, if we look into this, then we find that there is a continuum of object existence, that is, it varies significantly as to how long an object stays and where. And for example, the shortest living objects usually are the transitory objects, objects that get created because you just wanted to move some value from one place to the another. For example, if you know C++, the basic of C++, and you are returning a value by copy, then while you return that, the actual object that you are trying to return cannot be returned, because that object has to die as soon as the function call is over. So, what you do, you make a transitory object, you make a temporary object and return that. Or for that matter, if I am trying to evaluate something like a plus b plus c, then I cannot evaluate all of them together. So, what I do? I kind of evaluate something like T 1 is a plus b, and then T 2, say if this has to go to say x, then we say T 2 is T 1 plus c, and then we will say x is T 2, because at every time the object can do only one thing, only either add two numbers a and b, add two numbers, the temporary result of addition of a and b with c, and so on. So, these kind of objects are the transitory objects or temporary objects. They naturally have very short time span, because T 1 gets created here and will get destroyed here, it is done. Two different objects that we might need to keep in the database. Think about the leave management system. We have talked about so many employees of different types, and certainly these employees stay in the system for a very long period of time. Once an executive has joined and has been created in the system database, that employee object representing the executive will remain till that executive has been purged from the system, possibly because she has left or she is resigned and so on. So, the objects that exist in database often outlive. So, this is a very critical concept, outlive the execution of a single program, which means that the object representing an executive will remain much longer in the system compared to the method that needs to be performed for requesting a leave by that executive or by approving a leave for that executive and so on. So, based on this is kind of a continuum hierarchy of most transient to most persistent objects. These are expression evaluation. I just showed you an example that how transient values happen in expression evaluation. Similar things will happen for local function invocation. You know, whenever we do call by value, in C the values get copied and those copies will get removed when the function invocation is over. There are global variables, dynamically heap items, that means dynamically allocated variables which outlive the scope that they relate to, and so on till you talk about really data-based persistent objects in the database, which will outlive any kind of programs which create, manipulate and destroy them. So, it is very important to understand this continuum, and whenever you are designing the object, understand what is the persistence model of that object. For very simple things, for example, if an object is very transitory, it occurs and then disappears, then we would like to make it very lightweight. We will try to keep it very lightweight, because if there are too many transitory objects, they are getting created and destroyed very frequently. So, system will have a lot of overhead of simply creating and destroying objects. If an object is very large, it is huge, takes a lot of space, we need to make sure that it does not have ample transitory behavior. It should have more persistent behavior, and only a small part of that object which might need changes or which might need relocation will have to be treated separately, so that you do not get into performance issues. So, different aspects of persistence or different levels of persistence in time and in space will guide how we should design different objects, how we should encapsulate and modularize them, so that I can design a efficient system. So, these factors, this is the third factor that you need to keep in mind. So, to summarize, we have in this module talked about the three minor or useful, but not exactly essential aspects of object models, but I would assure you from my experience that if you want to do a good object oriented system design, or rather if you want to do a good design for a complex system, then alongside the major elements, it is very critical to take care of the minor elements, because minor elements relate to three major axes of implementation, which often turn out to be the core non-functional requirements of a system, leading to performance in terms of time, performance in terms of space, and general behavior of how responsive the system is, how robust the system is, and so on. So, please keep the aspects of typing in mind, which grades between strong, weak and no type, between static and dynamic, and is critical for OOP. You will need to certainly be conscious about the concurrency to be able to build client server models, and persistence will immediately tell you what kind of system you want to build. For example, a very simple example for persistence would be, you would need to decide whether at all the objects outlive your application or not. If they outlive, then your immediate conclusion is there will have to be a database. There will have to be a database to store. There has to be a persistent store to keep the objects, because otherwise all variables and objects that you create deal with in a program will certainly disappear, will get forcibly destroyed as long as your main function ends. So, you will not be able to work with them next time you run your program. So, these are the considerations that you will need to work with. So, with this I will conclude on the elements of object models, and next we will start talk about the other details of object models from the next module.